So in this video, let's see the proof of honors method. How honors method makes sense. How honors method makes sense. Well, let's proceed. Now, what do you do basically in honors method? We first draw two perpendicular lines, and we write the coefficients of f of x here, that is a0, a1, a2, and so on. And we write the polynomial with which we are dividing, like say alpha. And here first we start with a 0, and we add these two and write it, and we multiply these two, this PLY, and we proceed like this. So well, it comes to our mind, it is an obvious question that how does doing a simple addition and a multiplication make sense? How does it gives us the quotient and the remainder? Well, let's see how does it work. So first you have a polynomial f of x that is defined as a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2, and so on up to a n minus 1 x power 1 plus the constant term an into x power 0. And you are to divide this f of x with g of x whose degree is 1, and that is x minus a. Now let's suppose that the quotient function is q of x. This is the quotient that you get, and we are dividing f of x whose degree is n by a polynomial whose degree is 1. So the degree of the quotient will be n minus 1, right? So let's define q of x as, let's define it as q1 x power n minus 1 plus q2 x power n minus 2 plus q3 x power n minus 3, and so on up to qn minus 1 x power 1 plus qn x power 0, that is the constant term. Now in division we have a rule, that is when you divide say 10 by 4, how do? You divide 10 and 4 times 2 is 8, that gives you 2. So let me choose a different color. This is the divisor. This is the dividend, 10 dividend, and this is the remainder, and this is the quotient, right? So the rule is dividend is equal to quotient times the divisor plus the remainder. dividend is equal to quotient times the divisor plus the remainder. This is the rule, so we are going to follow this rule here. In our case, we have the dividend as f of x and the divisor is g of x, the quotient is q of x. Now let's suppose that we have a remainder r. So what happens here is f of x is equal to q of x times g of x plus the remainder, that is r. Right, now let's expand this. That is f of x is equal to, what is g of x? X minus a times q1 x power n minus 1 plus q2 x power n minus 2 plus q3 x power n minus 3 and so on up to qn minus 1x plus qn, this plus the remainder, right? So this is the case. Now let's multiply this x and a inside. Let's multiply this x and then this negative a in this. So what do we get? F of x is equal to q1 times x power n minus 1 times x, that is x power n minus 1, this power is 1, so x power n minus 1 plus 1. When bases are same, you add the power, so it gives x power n. So here what do we get? q1 in q1 times x power n plus q2 times x power n minus 2 plus 1, that is n minus 1, and so on up to qn minus 1 x square plus qn into x. This was with x. Now let's multiply negative a inside. So what do you get? Minus q1 a x power n minus 1 plus q2 a x power n minus 2 and so on up to qn minus 1 a x power 1 plus qn a plus the remainder.